Welcome everybody, both here and online. I think we have almost as many online as we do in here, or maybe more. So myself, I am very thankful to have a live audience. I don't know if any of you have ever done a class where you're just there sitting at your desk and trying to get people out there on the web respond, but it's not the most enjoyable way to teach a class. In fact, a number of us were in Texas a few months ago, where I have been going and teaching quite a bit. And a group of us instructors were at dinner, and we said, you know what, if we have to do it all virtual, we're done. We're not going to do it anymore. So it's great to have you here, which means what? I want to hear from you. I want your input. I want your questions. I want your expertise shared with the rest of the group. So this is a discussion more than me just blabbing on for hour after hour. Handouts that I passed out include my PowerPoint slides. And I have people say, well, you know, we're wasting a lot of paper. The reason I print these is because in every class, I'll have a half a dozen people that are feverishly taking notes. And when you're taking notes, you miss stuff. And so if you have the slides, you follow along in the slides, you can jot a little note there. And you don't have to write so much, and you'll still kind of be aware of it. So that's why I did that. Now I print it. So you turn the page up. If you turn it to the side, it's going to be upside down. So that's the way I printed it. The other thing, and some of you might say, oh, I already have this page. This is our quick guide for the residential in Utah. I put this together, and we've modified it and updated it 3 or 4 times now. It's been out since about 2017. This is a good basic guide on the residential energy code in Utah. And it also includes, I mean, how many of you have ever tried to take the state amendments and then go into your code and write pencil marks in your code to try to identify all the amendments? It's brutal, isn't it? So anything that has a state amendment, I have noted in red here. So, and it's a summary, it's not the exact text of the code. So you're welcome to use this to copy it. You can get it on our website. And if you have suggestions on what you might like to see on the next generation, let me know. And with that, I'm going to make a few comments about the energy code. I started teaching energy code classes back in like 2009, 2010, when the state had some of that recovery money. And some of you might recall, some of you that have been around a while, that we did what we called Morningside Energy Code training up at the Capitol. And we did those for about 24 months. And it was just a little short class that we do once a month, first thing in the morning. And they asked me to teach some of those. And I'll be very honest with you, I had a lot of people, good friends, and they're still good friends, that stood up and said, I'm not enforcing the energy code. It's ridiculous. The energy code isn't health and safety, which I dispute. But if you look at the code, what does the code say? It says health, safety, and general welfare. Now, I don't know how many of you like it, but last night I paid my property taxes. My energy expense, just barely with improvements I made on my home, became less than my property tax annually. So your energy bills in your home typically are your second greatest expense after your mortgage. Now, if that isn't general welfare, if that doesn't affect your pocketbook, I don't know what does. I hear too often that, you know what, every time we add something to the energy code, Like there was just a study that if we adopt the 21 code as written, it could add $3,000 or $4,000 to the cost of a house. Every time we add $1,000 or $2,000 or $3,000 to the cost of a house, the concern is we eliminate or remove a certain percentage of our population from that dream of owning a home. Well, if $3,000 on your mortgage is enough to prevent you from qualifying, how are high energy bills going to be a solution if you don't make a more efficient home? You see what I'm saying? That efficient, if you have an efficient home, maybe you can afford to stay in the house. So with that, most of you know me. My name is Brent Ursenbach. I'm 6 months from, and this makes me feel old, 50 years in the quote construction industry. I started in HVAC in 1972, June of 1972. So, and I have spent my whole career involved in HVAC, which directly ties to energy because the thermal envelope determines what size of heating and cooling system, how your duct systems get built. So that's what I've done my whole life virtually, and I have a passion for it. I think it's important. And above all, a well-insulated home with a good HVAC system is comfortable. And that is, for most of us, the big thing. I don't care if I spend an extra $20 or $30 on energy if I'm comfortable, but it would be nice if I didn't have to spend it and still be comfortable. Okay, so at this stage of my life, after a career in HVAC for 33 years and then another 13 years as a code official, a building inspector, plans examiner, I kind of semi-retired and went to work with WC3. I work less for them now, but I do continue to be the Utah's energy code instructor resource. And so I'm able to advise you, help you, assist you. If you have a question, you're welcome to reach out to me. I'll answer your question. I will not answer it that same day, probably. And it's best to email me. I get people that say, well, you didn't answer your phone. Well, you know, I am trying to not work every day, or I'm doing this and I can't answer my phone. But anyway, these people, Utah Office of Energy Development, Watt Smart, Rocky Mountain Power, Dominion Energy, Thermwise, and Department of Energy all fund me to be the energy code resource in the state. So you're welcome to get a hold of me. I provide classes at reduced or no cost across the state, which keeps your costs down. I wanted to quickly just share something, and I don't know if I can get that will go away. I guess we'll just work with it. Maybe I can. Let me see if I can get that to disappear for those that are here. No, I don't think so. Well, I can't even get to it from my screen right now. Alexa, do you know, do I have to try to drag that bar down? I'll fiddle with it at break. For 2 years, a group called IMT, Institute for Market Transformation, has been working on with DOE on a study. And guess what they did? They went across the state of Utah and inspected homes that were in various stages of construction. And what was their goal? It wasn't to say, oh, you're not enforcing the code, or you're not enforcing the code, or you're doing a great job on the code. It was just see the general overall compliance with the code and how we were building houses in reference to the energy code. So it's been going on for a couple of years, and in August, the report came out. Here was our team. You don't really care about that worked on this. Collected a bunch of data from the field with the goal of developing education. So based on what we have discovered, I am going to, through the next year, modify my energy code training to address the issues that we've discovered. And these are the things that were checked. Envelope tightness, which ties into blower door testing. And I know that we don't see a huge amount of that. Windows, wall insulation, ceiling insulation, lighting, foundation insulation, and duct tightness. And if you were to guess, would anybody guess which of those we could improve on the most?
6.
Foundation insulation. Kelly?
I was gonna say, what was building?
Number 1.
Number one was actually really surprising. Number 6, you're absolutely right in that we do a terrible job with it, but it's a small percentage of the number of homes we do. So the overall impact on our state energy use is smaller than that. Here's these are the number of homes they looked at in each one of these areas. So that was a pretty broad list. And did Kelly say the walls? The walls was the biggest one. Why do you think the walls was the biggest one?
Installation's not continuous.
Hey, insulation is not continuous.
Does it sell too? If they put in
Yeah, if they put it, whether poor insulation, installation. You know what the big one is? We have a state amendment that says you can use a special res check that allows you to do an equipment trade-off. So we have an amendment that allows building, you can build a house with R11 in the walls. We see houses all the time. In fact, my number one phone call I get from you folks is, this is complete BS. These guys are building houses with 2x4s and R13 in the walls, and it's passing res check. It's passing res check because they can trade off a high efficiency furnace. And we'll talk about that some more. But that's why that one's such a big number. And over statewide over a year, if we went to the 21 code, the savings would be over $500,000 in energy use. Duct leakage is the next one. How many see ducts and furnaces, air handlers stuck in attics all the time? The absolute worst place to put any of those systems. Ceiling insulation, envelope air leakage was better than we expected. So just the processes that we're using, it's better. So I'm not going to spend too much more time on it. I'm just going to load this up because I have a ton of slides I want to get to. So the insulation of the exterior walls and fixing duct leakage accounts for 70% of the savings recognized by through that study. Now this is modeling. I mean, it's not exact. It's as good as the information you put in, but the air leakage is quite low across all climate zones, which raises what concern? Mechanical ventilation. So we're building houses tighter than we expect we're building them, but are we mechanically ventilating them? Are we continuously ventilating these houses? No. And so we have houses that what?
Sweat.
They sweat. They condensate in the wall cavities. We have air quality problems. And it's because we piecemeal amend the code and we don't have a cohesive integrated code that works together for a good building. Now, as code officials and architects and stuff, we can only do so much, but there are some things we can do. And I think we have, real quick, code officials. How many code officials? Don't be shy. Inspectors, plans, examiners, whatever. Design professionals. Isn't that wonderful? I love having architects and engineers come in here. You guys have some expertise and you see it from a different side than a lot of us do. And I'm not going to tell my jokes about architects. You're all going to hell.
And the engineers too, though, right?
Architects generally. You know why? Jesus was a carpenter. No, I have dear friends that are architects and mechanical engineers and everything. And
You did.
no, you know what? Everybody has a huge job right now. The codes, I spend my time in the energy code and the mechanical code and the fuel gas code. And I get asked to teach a class on fire dampers. And what do I have to do? I have to spend a whole bunch of time in the IBC. And how many think that they are a real expert on the IBC? My hands are way down here. Now, maybe Alexa is. And George at the office is really good on the IBC. But guess what? George calls me and asks me mechanical questions. And so for us to expect this group of design professionals to know everything about the code, plus everything you have to know to do your job is ridiculous. There's just so much knowledge, and we just constantly have to work on it. So let's move on and let's talk real quick about this. Like I say, this handout gives you a number one thing on this handout is where you would start on any plan review, any inspection, any design, is what method of compliance are we going to use on showing compliance with the energy code. And I have 5 options listed. Is there any other part of the code that gives you 5 different ways to comply with the code? I don't think so. It's kind of crazy that we have a lot of options. Why do we have those options? So that you guys that are design professionals, your client can come to you and say, I want a unique house. In fact, I even see in Washington County, Climate Zone 3, homes that are being built with butted glass, which is, now they don't have a lot of it, but they have one wall of butt glass. And for those that don't know what that is, it's 1/2-inch thick glass or thicker. And it's just butted together with just a little bead of sealer between it. So you have this big expansive view with just a little line, and you don't have window frames. How efficient is it? Horribly. We don't have an airspace. But we do have an option in the energy code that says we can put it in this terrible piece of glass if we do what? A whole bunch of other stuff really right and exceed the code by a whole bunch. And we can do a trade-off. Now, the only place we can do that is in what we call the ERI, the Energy Rating Index, or the HERS rating. And that's because in that pathway, you get credit for your refrigerator, your dishwasher, and everything else you put in your house. So you can do lots and lots of things to improve efficiency so that you can have something weak. And that gives you guys some flexibility in trying to satisfy your clients' desires. But anyway, we're going to talk more about this as we move through. I did want to let you know that we have a website, utahenergycode.com. And on that website, if you go to residential, you'll find residential code resources and training videos. And on there, you will find this guide right here. You'll find all the amendments actually put into a sheet of the code. So there's a document there. Your compliance paths, those 5 paths, HERS raters, and an air barrier installation table that's out of the code. We have other videos and trainings that we've done over the past years that you can view. On the commercial side, we have a quick guide there also, and we have some resources there for the energy code. So feel free to go there. This is a work in progress. We're constantly fine tuning. What we have found on our videos is, like, we record this class today and we post it up there. How many people are going to bring up a YouTube video and watch 6-hour YouTube? Once in a while, someone, but it's a pretty small number. So what's our goal? Is to break it up into little pieces. And so that you could watch something on compliance options, you could watch something on mechanical ventilation and stuff like that. And sometimes we have live streams there, and we've had virtual field trips and such. But anyway, that's available. I also write, and others write, blogs. I get a question about something. In fact, this one right here I wrote about. I was contacted by a building department, a homeowner, and a contractor, and they were confused about how to do a conditioned crawl space. And this was a house built with a crawl space. They had insulated the exterior walls of the crawl space, but it was a ventilated crawl space. So they had all the foundation vents. What good does wall insulation do on a crawl space if you have foundation vents? Absolutely none. Well, with that, they'd run ductwork through the whole crawl space that was not insulated. This is in a cold northern county. And so by the time the furnace at one end of the house pushed air to the other end of the house, guess what? It was cold. And so I wrote about that one. A commercial one on hot water piping, townhouses. When you do res check on townhouses, what's part of the thermal envelope, what isn't? And so anyway, there's a number of things in there that might answer some questions, YouTube videos. Okay, now, some of you might have heard me in the past or heard others in the past say it's ridiculous. We didn't adopt the 18 code. We're not even going to look at the 21 code until next year, maybe adopted in 23, which means we're going to spend 7 years on the same residential code. And we might say, oh, that's shameful. We should be on the right code. Well, guess what? I don't think we're completely complying with the code that we've been on for almost 6 years right now. So maybe the next 2 years, while we're getting ready to adopt the new code, whatever it's going to look like, we can step up a little bit and do a little bit more and making sure we're complying. What are the issues? There's the big issue, too many homes fail to meet the minimum requirements of the energy code. My friend Mitch Richardson is one of the HERS raters, Building Science West, tests 3,000 to 4,000 homes a year. And he was doing tests and was looking at homes, new homes all across the state that failed to meet the energy code. And real easily, you could walk in and see that they did not meet the energy code. Now, what do these typical homes cost nowadays? $600 to $800, maybe we could be conservative and say $400 to $800. Someone spending $800,000 on the house, shouldn't they have at least a reasonable compliance with an energy code? I think so. So why? And what can we do? We can be like politicians and we can just point our finger everywhere, right? And it's everybody else's fault. I'm perfect, everybody else is wrong, right? This is who's, I think, has some responsibility. Anybody disagree? And I even put Doppel on there. I think the homeowner has the least amount of responsibility. especially the new homeowner. When I bought my first house, 1975, do you think I was concerned about anything other than I was actually going to get into a house with my wife and my newborn? No, I was thinking about a house. I didn't know. Well, I knew that what furnace I was going to put in it because that's the industry I was in, but I didn't know anything about home ownership. And so to expect the homeowner to be the expert is kind of ridiculous. So I'm just starting at the top of the list. And AIA, and you guys that are part of AIA know this, are probably familiar with this. They as a group recognize that may be the most significantly affected by and the most significant users of the codes. And so they say they have a duty to protect health, safety, and welfare. So the architects have a little bit of responsibility, and I was really seriously, I wasn't just joking, I was seriously excited when I have architects in the class, because if we can help you, everybody else's job further down the road is easier. If you can put out a plan that's compliant early rather than after 3 reviews, it's much better.
I give a contrary point of view.
Sure, please.
Homeowners, we find, tell us that using an architect is going to cost us more. So we don't want to use an architect because they just make things expensive. That's what homeowners and owners say. And having the owners be on board is going to make a bigger difference than anyone else.
You make a valid point.
When you bought that first home, if they said, oh, it's going to be 20% more, you'd gone down the street to the next seller.
You're exactly right. And I agree with that.
I also read 80% of residential homes in the construction in the US are developers and contractors. They are not architects.
Yep.
Residential.
Yep. No, and I agree. You know, and we have that big spread in residential construction. We have the production builders, and maybe they have an architect on staff. Maybe it's just a draftsman on staff, you know, that they change and stuff. And you're exactly right. If the homeowner took more ownership in it and didn't just push for reduce the budget, you know what I mean? Keep the costs down, because that ties your hands.
Then the next one that has the most influence is the laws, the legislators passing, adopting the codes, and then the code officials enforcing. Those 3 make a bigger difference.
Yep.
Than I've seen anywhere else.
Yep. And I don't disagree. I really don't, because you know, this finger pointing thing, everybody has a little bit of a role. You know, but I do believe that if you guys understand what the code allows and you know about the options, then maybe you can direct that customer better. But you know, it's an imperfect world, and you're exactly right. We would be much better off if we didn't amend the code like we do in Utah, because it makes it really confusing for everybody out there. If you didn't have a guide like this, how many really would pull out their code, download Utah Construction and Fire Codes Act, and sort through it and figure out how what every one of those says? It's brutal. I mean, how many have read that? Jennifer, you know how it reads.
I had to read it.
But it's tough, isn't it?
It's a long read.
I mean, it literally says in the 4th sentence of the paragraph after the word and, delete these words here and insert this. And so, I mean, that takes some time.
It's surprising to find out how many people in every one of those industries that you have listed have no idea, and people that have been around for a long time, that it's actually kind of shocking to know when you find out that they don't even know there's an industry.
Yeah. Yeah. So anyway, like I say, I'm just painting with a broad brush that everybody has a little bit of responsibility in here. I know that, like I did a lot of large reviews for apartment projects in California. These are big apartment projects in the Bay Area. And it was great when I did the second and third projects and the design team took those things that they had to fix on the first ones and implemented them in the plans, and we could move forward. So what I'm trying to put over is the better we educate everybody, the better chance we have of getting a good project. I mean, the ultimate goal is we have a home that's built that's energy efficient and safe and everything else. I'm going to jump on to the code official. I mean, you mentioned virtually everybody that really has a responsibility, and my list really says everybody. The building inspector is supposed to enforce the code. He doesn't have the option to decide, oh, I'm not going to enforce the energy code. He's required by his license. All of you that are code officials or inspectors, plans examiners, if you're a building inspector in Utah, you have to have a license. And your license, part of the requirements for your license is you enforce the code. And if you will be subject to revocation or suspension of that license or placed on probation if found guilty of unlawful or unprofessional conduct. And unprofessional conduct is gross negligence in the performance of the official duties of the building inspector, which is enforce the code. So we have, as building inspectors, a duty to enforce the code. Now notice it says gross negligence. If we just don't understand, I've walked out of so many homes, all you guys are building inspectors, I know you've done an inspection on a large home, complicated commercial project, and you walked out and you go, God, what did I miss, right? If you haven't done that, I'd be really surprised. You know, you have 3 more or 5 more or 10 more inspections to do. You know, did I miss something serious? Contractors, guess what? Their license says the same stuff. The contractor, nowhere in it does it say the contractor needs to do what the building inspector says. What it says is he needs to build in compliance with the code. Now, I do a little bit of expert witness work. Yeah, working for attorneys in construction litigation. And I can guarantee you that if you're in deposition or if you're in court and you say, well, it passed inspection, it must be right, it's never going to go anywhere. That carries no water. Because what's the attorney going to do? He's going to say, well, you're supposed to build to the code. It doesn't say anything about if it passed inspection. Jennifer.
So the most jurisdictions, I know early on, a lot of people argued it wasn't their responsibility because it didn't have anything to do with the health, safety, all that.
Right.
Have most jurisdictions gotten past that? Because I know I would ask for evidence of all these scenes, and when they go back to who they hired, they said, you know, do that.
The question is, yeah, it used to be that a lot of jurisdictions says, we're not going to do it. Like I said, we've improved. We still have some weak areas, some weak jurisdictions, for lack of a better term. And in fact, just as COVID was hitting, a group of us have put together a letter for all building departments that was offering that we come and visit with each one of them and help them with the process of either starting to enforce the energy code or stepping up to a higher level. And COVID, put the dampers on that. And so we continue to do this. So we've made some progress. Doppel has responsibility. Now, any of you that dealt with Doppel, and I agree, I've sat down with directors at Doppel and discussed this. that, yeah, they could do better, and yeah, they could use more people, and, you know, and a lot's expected of them. You know, they're expected to resolve all these homeowner complaints and everything else, and there's just so many hours and so many people, and so their desire is that we, rather than them use the sledgehammer approach and pound on every jurisdiction that's not enforcing and every contractor, it's more education. Let's try to train people. And so the short answer is, yeah, we've done better, but we're not there yet. We still have a long ways to go. Big box stores. I know that when the 2006 code came, we were enforcing the 2006 code, which was when we really first started enforcing the energy code generally across the state, that as an inspector in 7 and 8 and 9, when I went out on a home that one of the big box stores had put windows in, on several occasions, my inspection report said, please ask your window supplier why they installed a window that does not meet the minimum requirements of the code in Utah. And I have to give them credit that Home Depot and Lowe's both came out and changed windows out because they put in double pane vinyl without low E. So they put in 0.48 windows when the code was 0.35 windows. And if you go in there now, you'll see the windows all are 0.35 or lower. Some of them are kind of on the verge of not complying, but they're doing better. But they do provide contractor services, and those require building permits and inspections and such. So they have some responsibility. And the homeowner, the expectation, you know, needs to, they need to have some ownership on it. I just had a case down in Utah County. It did not go to court, fortunately, but the homeowner was really upset that they didn't have basically an $80,000 HVAC system, rather a $15,000 system that they paid for, and they were expecting the performance of the $80,000 system. They wanted precise temperature control in every room. Can you get precise temperature control in every room for $15,000 on a 2,500 square foot house? Nope. You have one furnace, one air conditioner, a big duct system with ducts up and down. That's what you get for that kind of money. So back to your point, the homeowner places a budget on what they're willing to pay, but then they expect a whole lot more than that sometimes. And that goes across the whole board. So
I just bought one a couple of years ago, but I didn't pay attention to it. Does he have to pass an inspection with the inspector that checks the house? Doesn't make that energy code evaluation or anything like that? Is that something that you guys are enforcing maybe in the future? Saying, no, it would be good to know you're buying a house that is bad in terms of.
okay, what you're talking about, he asked if there's some type of evaluation that can be made, right?
Yeah, that's not there.
Yeah. The ERI path that we're going to talk about does exactly that, and actually gives the home a score. My dream is that we get to the point that every home is scored, you know, at the end, and even existing homes are scored so that we really know how that home performs as far as energy goes and ventilation goes and all those types of things. So that's a great question, and we'll talk about that. Someone else? No, okay. Alexa, do you know what time we're supposed to take breaks, or?
I think the first break is at like 10.
Okay,
If you just talk and then you hear them.
yeah, when we hear them,
Yeah.
the herds out there.
Yeah.
So what's being missed? The number one thing being missed is that hasn't been identified which compliance option they're going to use. So one of the 5 choices needs to be selected, and they're right here. And we're going to talk about them, but it's a prescriptive table. It's a res check. It's what we call a performance model or taking that performance model to the next step, performance model on steroids, is the energy rating index. And then the fifth one is the Utah res check, which is a loophole that allows you to build a weaker home. And too often, the house gets built and no one even paid attention to, well, I don't know which path they used. Complete construction documents. And I'm not saying that you guys are putting out incomplete documents, but a construction documents for a residential project would be set of plans, an HVAC load calculation, some type of energy compliance document. If they're doing res check, it would be a res check. It might be just a sheet that says we're doing prescriptive and identify everything. Gas line diagrams, truss specs, you know, some of those things that you guys don't provide, but that's that whole package of documents that makes the complete set of plans. And when I say complete construction documents, that means that if the walls are R19, then the plan should say R19. The res check should say R19. The load calculation should say R19, rather than 3 different R values. Same for windows, same for lots of things. So that's complete construction documents. Did they blower door test, or did they do the inspection checklist? Open combustion appliances. You build this nice tight envelope, stick in an 80% efficient furnace and a conventional water heater, and you cut an 8-inch hole in the side of the building for combustion air. Why did we do all this air sealing if we just cut an 8-inch hole in it? The code addresses that and how we address that. Duct leakage outside thermal envelope. And it's not just leakage, but it's heat loss and heat gain. Putting ducts in the attic is ridiculous. And the HVAC load calculations. And ventilation. What's ventilation? Fresh outdoor air. Perfect. What's infiltration? I'm going to throw one word to that. He said air leakage from inside to outside or outside to inside, right? Either way, because if one happens, the other happens. Uncontrolled leakage. And that's what we have with a loose house. And people say, well, at least then we have air quality. Well, not really, because it leaks around the perimeter and it never addresses the interior of the space. And then when the wind blows, it blows right through the house. And so there's ventilation by infiltration doesn't work.
The ducts are sealed and insulated in the attic. Maybe doesn't that work? They're sealed, insulated.
Okay, the question is, if the ducts are sealed and insulated in the attic, doesn't that work? It does to an extent. What's generally the insulation requirement for an attic between the attic and the house? 38 or 49, right? And what's our temperature difference? Let's say summertime when it's really hot outside. Our temperature difference is 75 inch. We have 75 inside, and we'll go to I've spent days and days in hot attics in the summer, and I've been in many attics that are 140, 150 degrees. You instantly are sweating. If you're up there for more than 20 minutes, you're going to be sick. I mean, you really are. We'll be conservative and we'll just say it's 140. I've taken a temperature in St. George at 165. I mean, when you pull the access off, it's like opening the oven. So so if it's 140 in the attic, 75 in the house, our temperature difference is 75, is that right? 65? Thank you. 65 degrees. And heat flow depends on 2 things, right? Temperature difference and insulation, right? Those are the 2 factors. So we have 65 degrees of delta T or temperature difference. And then we put a duct in the attic and the air conditioner's running. And a lot of code officials, building inspectors say, well, we don't want to disturb the thickness of the insulation in the attic. So they make them suspend the duct up above the insulation. They do. I know it's crazy. And you're just going, oh my hell. But it's insulated to what? R8. So we have literally 1/5 of the amount of insulation. But what's our delta T? It's 85 because instead of 65, because the air for the air conditioning system is 55 degrees. So 55-degree air in the duct, R8 insulation, and that heat outside. I've taught, I don't know how many manual J, manual D classes in St. George. Between 25 and 50% of their cooling load is to overcome heat gain from putting that crap in the attic. Which means if you have a $400 power bill in the summertime for cooling, up to 200 of it, you're throwing away because everybody insists on putting the air handler and the duct in the attic. If we bring it inside the envelope, our heat gain is 0. Right? Does that help?
What's the reasoning behind having the duct?
I just was down there, met with DR Horton. They're looking on how, national home builder. And when they started building down there, everybody told them the subs, everybody says, oh, we just put them all in the attic. And they said, well, why? Because that's the way we do it. They build generally slab on grade. They don't have a basement. And so they don't want to give up any floor space for mechanical.
So would you solve it by then finishing the thermal envelope in the attic? So basically making
You can solve it by encapsulating the attic. Absolutely.
space on that.
Yeah. In fact, we'll talk a little bit more about those, but they're, yeah. In fact, the 21 code, guess what the 21 code says? The 21 code says, bury the duct in the insulation. If you're in a humid climate zone, encapsulate the duct with a minimum inch of closed cell spray foam. So, and then bury it completely in the insulation. Well, if you do that, you're virtually moving it inside the envelope because it's completely insulated from the attic. So and that's not just mine, the building science approach to this is, if you have to put ducts in an attic, dedicate a small closet for a furnace inside the envelope, blow up into the attic, extend your ducts out, keep them low, spray foam all the duct, which does what? Also, it creates a vapor barrier and it seals it. It is sealed almost perfectly then. And then bury it in the insulation.
Then if the attic ventilation, if it's a ventilated attic, the ventilation is good. the front would be harsh.
Exactly. And you've hit right on it. This last few months, I've had a couple conversations with people, and I can almost guarantee you that virtually every house you look at, every inspector in here, every house you've looked at in the last 5 years, I bet not 5% had code compliant attic ventilation. Next, go to Alcoa Aluminum or one of the siding manufacturers and look at how much free area you get through vented soffit. It's almost nothing. It's like a couple of square inches per foot of material. And we have this requirement that if, one square foot per 300 feet of attic area if you have 50% low and 50% high. If you don't have that, then it's 1 square foot per 150 square feet. That's a lot of square footage. Ridge vent doesn't fix it because ridge vent doesn't let a lot of air out. Turtlebacks, an 11-inch turtleback has a free area still by the time they put the screen and everything in it, somewhere around 70 to 90 square inches, which isn't even a square foot. So attic ventilation really compounds the problem. And that's why the number is so broad. 25% or 50% of the load is due to the ducts and air handler in the attic. My son used to live in St. George. And if you were sitting in the family room under the heat register, the supply air, and the system had been off for a few minutes and it turned on, guess what the temperature of the air was coming out? Well above 100. It didn't make it up to 140 in 20-minute off cycle, but it was really hot. And what do? You have to purge it all out. So where do you blow the hot air? In the house, and then you remove the heat with the air conditioner. There's our 5 options. I'm going to move forward. I am going to make a statement. Any jurisdiction out there that is saying you absolutely have to turn in a res check is wrong. That is not in the code. The code allows 5 options. Without state amendments, it allows 4 options. And only one of those 4 is a res check. So you're not enforcing the code if you make them choose one path when they have 4 options. Too often I've heard someone say, we don't review for energy in the office, we leave it up to the inspector. So if we don't review for energy in the office and they get out there and they put in $40,000 or $50,000 worth of windows and the windows don't comply, how successful would any inspector be out there and telling them, tear out all your windows? That one would go straight to the mayor so fast that, so it's really important that we catch just the basic stuff at plan review. It doesn't work. We have the 5 options. Res check is not mandatory. And I do want you to know that those options, a res check and the prescriptive option, we're going to talk about in a second, do not address air leakage. The other 2 do address air leakage. And so we have some mandatory air leakage requirements that applies no matter which option you use. So I already mentioned this, but construction documents, and this, when you see it, something in the box with the green text at the code section, it's on here. I've just snipped it out of there. State amendment says construction documents include all documentation required to be submitted in order to issue a building permit. U factors, R values, and other pertinent data must be shown and identical on all plans, energy compliance reports, and HVAC documents. My most common plan review comment has been in the past, no identified compliance option. No one picked one of the 5. And the U factors are different on the res check plans and manual J. And the R values, U factors, and solar heat gain coefficients aren't even on the plans or on some of those documents. Climate zones. We'll talk real quick about climate zones. Utah climate zones. They're based on counties. So is that 100% accurate? No, it's not accurate. Anybody ever been up to this building? It's a big building, isn't it? Yeah, we inspected those when it's a lot of glass. They did a model. That's how they passed. Yeah. No, it's not efficient, but it's cool. It's in Salt Lake County. You remember, Kelly, when we were doing that? We go right up the tram. That tram is so big, they hook bobcats on the bottom of it and haul bobcats up to the top. It's 20-something thousand square feet. And it's in climate zone 5. That's by code, that's all you can enforce, climate zone 5. And I don't think I put the slide in here, but no, I didn't. But our climate zone is based a lot on the data at the airport, because that's where we collect temperature data. Is that the worst place in the whole valley to collect temperature data? Actually, it is, because it is tempered on both ends, both cold and hot, by that great big lake that's right next to it. A week and a half ago, the airport had the first frost. I live in South Jordan. By the time we had one at the airport, I'd had 6 at my house. And there was lots of places in the valley that I had frost. So, but the climate zones have been picked to generally fit the majority of the population in the area. So what do? We recommend, this is really climate zone 7 or 8, because the design there for HVAC from ASHRAE is -15. And the wind is high because you're right at the top. So that's really, but you know, we can't enforce more in climate zone 5.
The code official also put it on the code. The code official is the last one. You could enforce it.
I could not enforce a higher, by code, I cannot say no.
Really? Because we have things in instances in architecture that if the code official says, well, I don't care what the book says, I'm telling you to do this, then you say, okay, I'm sorry, I do it.
There are code officials that say, I don't care what the code says, that's what I want you to do. But that's not in their authority. Is that right, Jennifer?
The same ones that are still working off the 79 code, right?
Yeah. And you know what? For code officials out there that say that,
Would you not have the ability under the authority of or having jurisdiction for your jurisdiction to say, hey, you know what, we have specific needs within our jurisdiction that may not apply to the county next door. Therefore, as the code official, we would implement this because we know this to be a proven, you know.
you make a good point. And for those who are online, can the code official, like the code official for, well, Snowbird isn't a town, but Alta right next to it is a town. Can the code official for Alta say, no, we are climate zone 6 or 7? As the AHJ, he doesn't have that authority. What he does have the authority to say or to do, and this is in state statute, is to go to the legislature and say, I want to amend the code for Alta, or I want to amend the code for South Jordan, or I want to amend the code for Farmington, and Farmington does have some.
We do that.
Yeah. But to do that, it has to go through the legislature and be approved as an amendment.
Well, that goes back to, like, well, Farmington, for example, used to require so much rock and stuff like that. It got to the point where people said, you have to have a specific code for every city you work in. So the legislature came and said, no, you have to have a reason and come to us to get that passed. So.
And I've been involved, and I didn't want to be, but I'm going to be involved again next year as the legislature reviews the legislature doesn't review it. The Uniform Building Code Commission reviews the codes with their advisory committees, then makes a recommendation. And I'm going to end up working on it again. But I am seeing right now legislators and interested parties that are writing code changes that cripple building departments. But it's because building departments were overreaching their authority. Let me give you an example. We have both sides. I agree. Some of the changes are made just because they want to or they don't like it. But we have in the code that you cannot run gas lines through individual units in townhouses, right? Does the code have the same thing about the electrical service? No, it doesn't. But we have a lot of jurisdictions that have been enforcing that. And they did it to a member of the legislature who's a builder And it cost him something like $80,000 to bury services and run them around the outside of this townhouse project, which the code didn't require. And when he found out that he had had to spend $80,000, what happened to that code thing? They said, well, guess what? You can run gas lines through the units. Fortunately, we got in there, they have to have an easement recorded to run those utilities through them. And we got that they can't do it with CSST, they have to do it in black iron, black steel pipe. And we got it, we at least made it so that it wasn't a dangerous thing, but we sometimes, and I know it's righteous, good intent, you know what I mean? We're trying to make sure we're building a better building. But if the code doesn't allow us, if the state statute doesn't allow us to do it, then we're kind of.
Are the different AHJs allowed to, like you're saying, with wind speed, allowed to adopt climate criteria for each, like, town or?
They could, but they'd have to take it. They'd have to take it to the legislature. When a project is finished, there's supposed to be a certificate posted someplace. It used to say in the electrical panel. It now says someplace that's conspicuous around the panel or in a mechanical room that identifies how the house was built. Here's our options. The first one is a prescriptive table. What's a prescriptive table? It's simply a table, and I have part of it on here, just the part for Utah. Let me see what the next. Here's the prescriptive table out of the code. And basically it has all the different components of the home, all the climate zones running up and down. And you just go across and climate zone 3, here's what you're supposed to put in it. Those are the minimum requirements. Climate zone 5, here's minimum requirements, climate zone 6. Those are printed on here in this little table right here. So we can, in climate zone 5, where we are right now, make sure we put in 0.32 or lower U factor windows, 0.55 on skylights. We don't have a solar heat gain coefficient requirement. Put 49 in an attic, put R20 or 13 plus 5, which is 13 in the cavity and 5 and foam on the outside. Mass wall, basement walls, 15 continuous or 19 in the cavity, and same for crawl space. Whatever components you have in your house, if you meet every one of those, all you'd have to do on the plans is say compliance per prescriptive table, walls, this level of insulation, and just detail those on a sheet on the plan, and then make sure that the sections and elevations showed those R values. You comply. Well, guess what? Maybe you don't want to put R20 in the cavity, or maybe you don't want to put R49, you want to do R38, or maybe as few of your windows are going to be around 0.33 or 0.34. If you can't comply with every single thing here, then our next option would be do a res check. And what does the res check allow you to do? Trade off. I'm weak here, so I'm going to go better here. Straightforward, pretty straightforward.
I'm not familiar with the residential code. Is there a U value prescriptive chart as well, or just R value?
Yes, there is. There is. Yeah.
We find ourselves like trying to do a lot of continuous, and we get insulating a metal sub wall is stupid, right? So
Yep.
meeting the U factor of those walls is probably.
Yep. The question is there a U value table in the residential code like there is commercial code? And there is. I'm just going to add a comment real quick. When you use a U value table, or when you pick other in a res check or a com check, if you have an assembly that isn't listed in the drop downs, it's called other. Are you familiar with that? You have to provide some type of documentation that show how you came up with the U for that assembly.
I've done it before. Usually we end up doing like energy models or contract either way, but typically that would just be manufacturers test the data to the ASTM, right?
Yep, that's fine. But sometimes you end up with a wall. Well, tilt up. How are we doing tilt up now? It's actually really cool. They're sandwiching foam in the tilt up panels. And maybe there's some tested data now, but it's pretty simple because it's concrete, continuous insulation and concrete. You add them up, you know, because there's no cavities, you know, there's no thermal bridging between it. So anyway, res check is pretty straightforward. Now, when someone complies by prescriptive table, if they do a res check, guess what? It's going to pass. I mean, it's going to pass every single time. But the res check does give you a couple of other things. It gives you credit or it penalizes you if you have a lot of the foundation exposed. Because when we pick basement wall, it's assumed that it's generally below grade. But if we expose a lot of it, then we have more heat loss, we have more conductivity to outside. And it does take into account some of those things. But there's the res check. Now I've thrown in a couple of res checks simply to show how screwed up they are that I see. Now someone sent this to me and I didn't white out everything. I whited out who the contractor and stuff was. But it is in Washington, Utah, so it's in St. George area. And you see they wrote my name on it so that when they send it to me, because it passed by 53.3%. And the building official looked at that and went, oh my heavens, it's 53%. There's got to be something wrong. And he looked down through it and he really didn't know what it was, and that's okay. But what he has here is a window with a U factor of 0.05. Now, I think there's some people in here that understand that that is an incredible U factor. It's exactly 1 divided by 0.05 is 20. I tell you, please, if someone knows how to make an R20 window, I don't even care if it's really expensive. Let's get together and let's become billionaires, right? Can you get a solar heat gain coefficient of 0.05? Yeah, you use 3 inches of foam, right? And so that's why it passed by 53.3%, because they put in a bogus number. Now, this is what I was talking about at first. I can guarantee you not everybody in here recognizes a 0.05 window. There's something wrong with that. And there's nothing wrong with you not knowing that, because that's just one more bit of information you need to tuck away in your head. That's a crazy number. It just a completely insane number. And in fact, I see on comm checks, and you do comm checks, I see comm checks, and 8 years ago and stuff, I saw comm checks all the time that had storefront windows at 0.25. Alexa's over there shaking her head. No, no, you can't do that. Who makes that window, right? Yeah. But she knows because she does reviews and she's at George has taught her, or I've said something, or what's the problem with storefront windows? Aluminum frames. It's really hard to get down into the 3s, the 0.3s with aluminum frames. But how do you know? I guess you come to classes and we talk about it, right? Really hard because of the conductivity of the frame. The U factor on a window takes into account the whole assembly, the glass and the frame. There's big buildings all over the country that were modeled with 0.25 glass, and these are buildings that are almost all glass. when in fact the U factor was 0.5 or higher. So what would that do to the model? The energy consumption is where? Doubled. We doubled the conduction through the windows because we put in a factor for just the IGU, the glass units, not accounting for the frames. Here's another one, Washington County. This one, they were throwing in crazy numbers for continuous insulation. They were trying to take credit for the drywall and the sheathing and everything like that, which is already included. When you pick a wall assembly, that's taken into account. But they were trying to get it to pass and they barely got to 0.19. But the problem was they put in their windows at 0.8. Well, they were shooting themselves in the foot because 0.8 is a horrible window. 0.8 is a double pane aluminum frame window with no thermal break. That's a terrible window. My house I'm in right now, when I bought it, had those windows in it. And they suck. They're terrible windows. You know, I'm pointing out a few things to look for. Slab on grade, 3.8%, 3.7% better than code. They're putting in, this raised a flag, 112 square feet of garage door. Are we including the garage in our res check, or what are we doing here? Front and back doors at 0.5, that's probably a bad number. And then they have this 0.38 insulation. Is that on the plans and what is it? Then they're putting in the party walls. If we have townhouses, the party walls are the common walls. Are they part of the thermal envelope? What's the thermal envelope? Separates conditioned from unconditioned.
Do you have, so I know like when I model like Wolfie modeling, when I do that, I have to give it, it's like a not semi-conditioned, but there's another 2 4 feet like a party wall. Do you not, does ResCheck not do that?
No, what you're talking about is partition walls, where it's not outside temperature, but it's ResCheck doesn't go that.
What's on the other side, so at least like Wolfie would say like it doesn't give you full credit of being interior, but it knows that it's not exterior.
Yeah, when you get into a large commercial building like you're talking about, we can generally assume that the temperature in the parking area or something, you know, and the floor, you know, if you're looking at the floor, the temperature down there is going to be generally in this range. When we get into residential, we really can't make the assumption, and I didn't make the assumption when I did residential load calculations. I've done thousands and thousands of them. I assumed that that home was going to be owned by someone like 3 or 4 of my neighbors in every neighborhood I've ever lived in that never closed their garage door. And you have neighbors that don't close their garage doors. And then their stuff gets stolen, and right? But there's lots of people that never close their garage door. Yeah. Yeah. Instead of going to the dump, put it all in your garage and leave the door open, right? So no, the residential purposely has tried to be simple, make it simpler.
So it doesn't take into account air leakage.
Well, it does take into it.
Square footage to do that.
It does air leakage, but that's separate from this. Great questions. Here's another one passed by 7.6%. They have 2-way windows all over, and they have 4 R4 continuous insulation. That's great if they do have R4 continuous insulation. This column, cavity R value, continuous R value. Cavity insulation is what's going between framing members. Continuous insulation is what? Typically outside, penetrated by nothing but a fastener. An attic with trusses, blown insulation is not first 3.5 inches a cavity and the rest continuous, because why? Because when we look at our trusses, we have these intermediate members of our truss that are coming up through the insulation. And if you take a thermal camera, you can see exactly where those are from the conduction that occurs through that framing that penetrates the insulation. So any insulation in a blown attic is cavity, the full depth. I'm going to go really fast. Lots of the questions I receive could be answered in Res Check Help. And if you want this, what I did, you're in Res Check, you click on Help, and it comes up with all these different pages of assistance that it gives you. And they don't give you the option to just print it. And so I've had to snip all the pages out. And I've created a PDF that has them all. But here it talks about flat or scissor trusses, different types, cathedral ceilings and such. Raised or energy truss. What's an energy truss? That's where you have a high enough heel at the outside wall that you can get full depth insulation all the way to the exterior of the building. Makes a big difference. In fact, it makes such a difference that if you are doing prescriptive table and your requirement is R49, if you put those trusses on, you can put R38 and have similar performance. Actually, you're going to have better performance because you're not going to have the condensation occurring around the perimeter where you have this much insulation. Floors, talks about slab on grade floors. What is slab on grade? Less than 12 inches below grade. Gross area of the floors, continuous insulation. That's where that comes from. Assembly U factor discusses that depth of insulation. If you're slab on grade, the perimeter insulation has to come to top of slab, like this. And someone mentioned,
That's what I was referring to, is more form slab on grade.
yeah,
Conditioning foundation.
yeah, these are energy pigs if we don't do them right, and they're very often not done right. But they're not. The table and the study was looking at the potential savings in Utah. And since we don't have that much slab on grade, it didn't make as big a difference as some of the other things, simply because we don't put it on everything. How do we determine the size of a log? Talks about cavity, R value, basements, and insulating and wall heights. Here where it talks about how deep are we burying the foundation. I've had res checks turned into me that just barely passed, and they said we have 8-foot walls, 8 foot of insulation, and 8 foot of dirt on the outside, which means they were buried right to the top of foundation. And that's what they did to get it to pass. When you put the 18 inches was exposed, it didn't pass. And it's because we're exposing not the foundation, not to dirt, but to outdoor cold temperatures. Discussion on windows, what we put in, when's the door solid, when it's glass. So real quick, if you want a copy of that, send me an email and I can send you the full document, or you can just download Res Check and go to help and the whole thing's there. Here's the energy model. This gentleman right here is talking about, you guys do some energy modeling. And I'm not going to spend much time on it because residentially, I hardly ever see this. I mean, like I've seen it twice in 13 years. Yeah. 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 And in the past, that's where we saw them. But now anything like that, they're going to the ERI path, which is, just that taking a step further, that model. So basically you model the home against a standard reference design home. The code specifies what the requirements are there to the home that you're going to build. There's some challenges with it because it only allows so much window area. So if you try to model a house with excessive window area, it'll never pass. And then the energy rating index, or the ERI path. And this one I want to spend a little bit of time on because I really hope that, I mean, really, this is my dream at some point in time. This is the way we show compliance with the code. The code calls it an energy rating index. And then I have HERS rating in parentheses. What's the difference? Anybody know? The code put in energy rating index as a generic term. It's a rating, it's a number, it's an index, a rating we give a home based on criteria listed in the code. Currently, there's one system in place, and that's a HERS rating. The code did not put in HERS rating because that would be the code basically saying you have to use ResNet's system, you know, for this energy rating index, and ResNet's a private corporation. ResNet's the only one that has a system now, and many of you have heard of it. If you ever done any Energy Star or anything like that, they do HERS ratings on them. What's a HERS rating or a HERS index? So if I call it ERI or HERS, it's the same thing. If you build a home compliant with the 2006, just exactly compliant with the 2006 ICC residential, it will have a score of 100. So if you have built a home less efficient than the 2006 residential code, you're going to have a higher score. If you build a home that's 10% more efficient, you're going to have a score of 90. If you build one that's 50% more efficient, you're going to have a score of 50. So what's a score of 0? What?
You're outside.
No. It's a net zero home. A 0. Now, a high score would be you're outside. Yeah, so the lower the score, the better. So a 65 means you're 35% better than 2006 code house. Now, why am I so crazy about this? Well, let me back up. Notice red. What do the little red boxes mean? State amendments. So when this came into the code, the state legislature amended it and raised the number and said, oh, if we use this method, you don't, on climate zone 5, you only have to get a 69 or lower to comply. Well, if you look at the numbers around there, you can see that that probably is somewhere around 12 to 15% higher than, and really the number should be somewhere around 59 or 60. Two things happened. When this was put into code, the people that sponsored it were a little bit overly zealous and put in a lower number than's comparable with the rest of the code. So these numbers were too low. And in fact, in the subsequent code, the 18 code, these numbers have been raised a little bit. They're halfway in between these numbers, and you know. So it's another thing with state amendments. If they choose this path, getting a 69 in climate zone 5 is pretty simple. Really, it should be closer to a 60 or someplace in there to really be equivalent to the other compliance options. But that's how it works. Why do I like this? Because if someone's going to go buy a house, and if you had two houses that were quite identical, you were talking about if it's $20,000 cheaper, they're going to go to the other house. So you have two houses that are fairly close in price. They have the similar features and everything. If you had an energy score for it, might that help you make your decision? especially if there was a big difference, guess what? The builder gets rewarded for building a more efficient home. He gets money for spray foam or foam on the outside or better windows. He gets some, it's recognized in the value of the house if we have an energy score that's low. Can you score existing houses? Yes, the HERS rater can go into an existing house and give it a score. You know, when I first bought my first house back in the early 70s, there was no such thing as home inspectors. And I'm not going to get into a discussion on home inspectors because there's some good ones and there's some that aren't quite so good, right? But can you buy a house now without getting a home inspection? In fact, a lot of mortgage companies require a home inspection as part of underwriting. Wouldn't it be more intelligent if the mortgage company required a HERS score as part of underwriting so they could really determine if they can afford to stay in the house? A $200 or $250 a month energy bill is part of what you have to pay every month. You know, their car payments and their credit cards and all those other things are accounted for. Why would you not account for an expense that's there every single month that you really have no control over? So this would really solve a lot of problems because we wouldn't be arguing about the energy code and trying to tighten it up because we wanted homes to be more efficient, because once the public knew about this, it would drive it to drive more efficient homes. The mortgage company recognized it would drive it because they'd say, well, yeah, you can borrow another $20,000 because your home's super energy efficient.
Not that you, but when you do the HERS index, do they tell you, imagine you got like 120.
Yeah.
Does it tell you at least a couple of pointers of what it should be done, not done, etc. to at least make it better? Hey, change your windows. You have single pane or double pane.
Yeah. The question is, does the HERS index tell you where you're weak?
Yeah.
Yep, it does. Yeah. It's I think it's a really cool system. The fifth option, I mentioned it earlier, this allows an equipment trade-off. Now, a little background on this. Back in 2006, we adopted the 2006 Energy Code, and we enforced the 2006. Well, we started enforcing the Energy Code in 2006, and it was a simplified code from 2003, because the 2003 did not use county lines to identify climate zones. It used heating degree days and cooling degree days. And you're familiar with what those are, but I bet most people in here are not familiar with what those are. And it's an assigned value that's, you know, you're so many degrees above this temperature on average every single, you know, and they account for every day. So it's basically how many days are you above a temperature or below a temperature and by how much. And so it's a number for all different locations. So the first thing you had to do in the 2003 code was try to figure out what the climatic conditions were in heating and cooling degree days for the location. And then you tried to decide, and then you decided between 17 or 18 climate zones where you were. Guess what? No one did it. And so no one enforced the 2003 Energy Code. Kathy, do you remember anything before 2006 though? Yeah, it was, you had to do your own UA calculations. You had to do, I mean, it was.
Very complicated, really solid level education.
And even today, it would be really hard. And so 2006 was real, code book was this size, it was real simple. We went to the 8 climate zones, you know, we did this simplification, and it did include the equipment trade-off, which meant you got credit for a 90, back then it was 91 or 92% efficient. Now it's 95 or 96% efficient furnace. You got credit for it. You got credit for your air conditioner if it was higher than the federal minimum standard for the air conditioner. 2009 code comes around, and it disappeared, that equipment trade-off. Why did it disappear? Because we had one shot to build a good wall. You build an R13 wall today, how do you improve it later on? It's expensive, isn't it? It's really expensive.
Yeah.
And so I'll finish this bit and then we'll take our break because it sounds like it is time. And so we did not adopt the 2009 energy code. We stayed on the 2006, and we didn't adopt the commercial code either. And so 2009 comes around and the legislature said, okay, we'll adopt the code with all these amendments, but it's not effective until we get a res check that allows an equipment trade-off. So guess what our job was? Convince DOE to pay Pacific Northwest National Labs to write a res check for Utah that included an equipment trade-off. That took another year and a half, and if you recall, we did not adopt the 2009 energy code until it was like, I think 2011 or something like that, because we had to convince DOE to do this res check for it. Guess what DOE said after they did that? And they did it for 8 states or 7 or 8 states. Never again. So they won't do that. So we have stayed on that 2012 code with a little bit of changes, moving forward into the 15 code. And we've been on the 15 code since 2016. And we still have this compliance option. If you're in res check, and I'm sure some of you have downloaded res check, and you go up to pick code, it'll say Utah 2012. But when you print the report, it'll say Utah Energy Conservation Code. And it does allow you to put in 95% efficient furnace or whatever you want to. And you'll have some high numbers. So if you build a pretty good house, since this is based on a weaker code, you're going to have high numbers because the 2012 code is weaker than the 15 code. So, but it's still an option we have. This really, when this came about and we got the new res check before it was adopted, I ran between 50 and 100 res checks with this res check and with the 15 res check, the 12 res check. And the number should have been somewhere around passing by 10 to 12% to be equivalent. The legislature didn't go that way. They started out that you had to pass by 3%, 4%, and now 5%. So we still get between 5 and 7% weaker home if we use this option. But we cannot deny them to use it.
Question. The reason that like you can get up to 3 stories that falls under like a R2 occupancy that falls under the res check. That's kind of where that crosses the bridge into the com check once you go to a 4-story room. Does this play into that? Is that one of the reasons?
This plays into it, but the question is why is let's just say a 3-story apartment building, we don't build it out of the IRC at all. We build it out of the IBC and the IMC and the IPC and everything else, but we use residential energy. And it's because ASHRAE makes the division between low-rise and high-rise residential buildings. And ASHRAE has defined it 3 stories or less as a residential building. And so to just try to match ASHRAE, that's why a 3-story residential apartment building, no matter how many units, you have to use this versus ComCheck. And it makes it really messy because you have projects that have 3-story, 4-story, and 5-story buildings on it. And so some have to be res check and some have to be com check. And when they're res check, they have all the amendments. If they're com check, you don't have any amendments, right? Let's take a break.